Hello, welcome to the session. My name is Saroj. In this session, we'll discuss about the Hadoop Daemons. So, what is daemon? So, daemon is a service, or it is a process, or it is a program which is running in the background of the system. So, the daemon is a listener. It is a housekeeping guy in the hotel who can get the request from the client, and that request can be carried out by the listener, the housekeeping guy, and it will give the request to the management stating that so and so service required by the client, and that service can be taken by the housekeeping guy, the listener, and giving the service to the client. The same way here, the daemon is a service. It can be accept the request from the client machine, and it will be given to the system, and the system is process the request and gives back the service to the listener or to the daemon, and daemon will give the process service to the client. So this is the functionality of the daemon. So in our Hadoop cluster, we have different daemons. As I said, there is a master node that is called name node. So the daemon having the lot of importance in the Hadoop cluster. That's why the naming convention of the machines are given as per the daemon. So name node is a master node where the name node daemon is running in the background. In the same way, I have another component called master node that is called second name node. It is a machine where the secondary name node daemon is running. And there is another component in the master node which is used for the processing of the job. That machine name is a job tracker. So the job tracker daemon is running in that machine to do some processing. And the data node, there are different data nodes are there in the cluster. Data node 1, 2, 3 and 4 here in this example. So the data node 1 should run with a daemon called data node daemon, and data node 2 also, it should run the data node daemon, and so on. In each and every data node, the data node daemon should run so that it will do some tasks. It will do the storing of the data. The same way, to process, the daemon should run, that is called task tracker. In each and every data node, we can have the task tracker daemon should run in each and every machine to do the function of the tasks, processing tasks. So when the client want to store the data in the Hadoop cluster, it will contact to the name node, and the name node will give the guidance where to store the data. Like data node here in this example, data node 1 and data node 4 has been picked off by the name node and given the client, stating that to store the data, your blocks into the data node 1 and data node 4. So the client will store the data in the data node 1 and data node 4. The blocks are stored. Block 0 is in data node 1 and block 1 is in data node 4. So if the data node daemon is not running in this cluster, it cannot accept the data. If the data node daemon is not running in the data node 1, it will not accept to store the data, to store the block of the data. The same way, if any data node is not running with a data node daemon, it will not do the storing of the blocks. The same way, if the master node is not running with a name node daemon, the master node will not function. If you store any data in the Hadoop cluster, it will be through an error saying that connection refused because the name node daemon is not running in the system. So to do function of the Hadoop cluster, all the respective daemons should run in the respective data nodes, in the respective master nodes. So that is the importance of the daemon. So here the client want to process the storage wise, like if all the data nodes are running, data node daemons are running in the data node respective data nodes, and the master node and the master node name node daemon is running, then I can store the data by contacting to the master node, the name node, and it will be store the data in the Hadoop cluster in the different data nodes. The same way, if I want to process the same temp.txt file, the client will contact to the master node, that is called job tracker, and the job tracker has no logic to process the data. So what it will do is it will contact to the master node, the name node, saying that, hey name node, I have the input file like temp.txt file and I have the logic with me, but I don't know where the blocks are present for this file temp.txt. So please provide me the complete path, complete information of the temp.txt file and block information where I can process my logic. So the name node will provide, it will give the complete information by reading the metadata from the system RAM, system memory, temporary memory, and it will give the information saying that the B0 is stored at a data node 1 and B1 is stored in the data node 4. So the master node, the job tracker, now having the information, so the job tracker is keep in touch with all the respective data nodes of task tracker. The task tracker is a daemon which is required for processing the data. So it will contact to the data node 1 of task tracker saying that, hey task tracker, I have the logic and I have the input file temp.txt file and you have the block, small portion of the data like B0 is stored in your data node. So please process the data, I have the logic, execute the tasks. So the task tracker will accept the request and it will be execute the block 0 in data node 1. The same way, in that the same time, it will be getting touch with the data node 4 of the task tracker. The same thing will happen here. It will be send the logic stating that, hey task tracker, I have the logic and I have the input file with, and a small portion of the data is like B1 block 1 is in your data node. So apply the logic and execute the tasks. So the task tracker will be execute the block B1 and it gives back the status to the job tracker. The task tracker of B1, B0 and B1 of data node 1 and data node 4 will report back to the job tracker the status. The periodical status will be given to the job tracker. So how far the job has been completed, is there any issues faced by the data node 1 and 4? So that type of status will be reported to the job tracker, and the result of the data node 1 of the task tracker will be sent to the job tracker, as well as the result of B1 by the data node 4 of task tracker will be report back to the job tracker. and the consolidated result will be, all the results will be consolidated by the job tracker and sent back to the end user or the client. So this way the processing will happen. So what we have concluded here is the daemons are taking place very crucial role in this Hadoop cluster to function properly. So there are many daemons like name node, as I have stated. Name node, it is a master service who is going to manage the metadata in all the slave nodes. So this machine, the name node, is, if the name node daemon is running, then it can store the metadata and it will help to manage all the respective data nodes. If the name node daemon is not running, it will not function properly. It will not function at all, stating that connection refused while you put any file or if you want to process anything. Not processing, exactly for the storing purpose. It will say that connection refused. So we have to run the name node daemon. It should run forever in the background. The same way, the data node, it is a slave service which is going to store the actual data. So if you want to store the data, the actual data can be stored in the data node, and the data nodes daemon should run in each and every data node machine. Data nodes. And second name node, it is a master service which is going to take the backup of the metadata from the name node. Here, if the name node contains the metadata, if the name node goes down, there is another master machine I have connected in my cluster that is called second name node. The naming convention is wrongly given because it will not function what the second name node does. If the the master name node fails, the second name node should take over the complete control and it will function properly. But here it is not like that. Second name node is only a checkpointing system. It will copy only the metadata. If the name node having some issue, or if the name node metadata have lost, then I can copy the metadata from the second name node and I can make my master node up and running, and I can get the access. I can access my data properly. I'll explain what is the complete functionality of the second name node in my upcoming sessions. So if the second name node daemon is not running in the master node of another system, then it will not take backup of metadata from the name node machine. So this is the importance of the daemon. So if the daemon is running, then only the second name node machine will take the backup of the metadata from the name node. And the job tracker, it is a master service which is going to manage all the MapReduce jobs. And the task tracker, it is a slave services which is going to do the actual tasks. So as I have explained before, the job tracker is responsible for the processing of the job, that is called MapReduce job. So if job tracker is not running, it will not accept the request from the client machine to process the job. And the task tracker is running in each and every data nodes. If the task tracker is not running, it will not accept any tasks given by the job tracker. So to run the cluster properly, all the respective daemons should run in the background. So that is the importance of the daemon. And I'll explain practically how the daemon is running in the background and how it is happening, etc. And how to start the daemon, how to stop the daemon. I'll explain well in advance in my upcoming sessions. And the services are divided into two categories. One is DFS service and another is MapReduce service. So the DFS is related to the data storage and the MapReduce is related to the job processing. So here, like the name node and the data node and the because name node is managing to store the metadata, so something related to the storage. The second name node also, it will copy the metadata, so it is also related to the storage. It will store the metadata, it will take the backup of the metadata. And the data node, which is running in all the data nodes, it is also res responsible for storing the actual data. So these three daemons to combine form a service called DFS service. DFS service. Data node, name node, and the second name node. Three daemons combine to form DFS service. If somebody says what is the DFS service, we can say three daemons. And job tracker and task tracker. It is completely related to the processing. Like the job tracker is helpful for processing the tasks, processing the job. In task tracker, without task tracker we cannot process the data. So with the help of the processing components, processing daemons are job tracker and task tracker. That's why we can say it is a MapReduce service. So this is all about the daemons. Thank you.